Hey, VIVA is the most crucial part of board practical examination. It tells you how well prepared you are for the forthcoming examination. It has important impact on board practical marks. You need to prepare it well. I'm Rajkumar Parishari, physicist and a teacher, and I love doing in-depth analysis of physics related topics. Today I am here with the VIVA questions on optics related experiment, particularly to find focal length of a convex lens by plotting U versus V graph. Dear students, you need to assume that you're sitting in front of an external and VIVA questions are about to be asked. You need to sit with pen and paper. I will ask a question and will keep pause for about 10 seconds. You can try answering question at your own. Yes, you can pause the video to answer a question. Either answer it while speaking or write it on a piece of paper. Once set of 5 questions is over, I will start answering questions one by one. So, are you ready? Dear examinee, here is the first question for you. What is a lens? You know it. You have seen this. Can you put this in your own words? Also think of various types of lenses. I guess you're done. Here is the next question. What is an optical axis of a lens? Come on. Optical axis is also called as the principal axis. I guess you're done with it. Now the next question. What is focus or the primary focus of a lens? You have done it in class 10th. You should be able to recollect. Next question for you. What is focal length? Pretty simple. You're smiling. Finding questions simpler? Don't worry. Wait. Here is the last question of this set. Define first and second focus of a lens. Also, try to relate second focus with the principal focus of the lens. Come on, recollect first and second focus of a lens. You must have drawn. I presume you're done. Now, I'll start answering these questions one by one. So the first question happens to be, what is a lens? Also mention its types. Answer. Lens is a transparent medium surrounded by two surfaces. One of the surface need to be curved. It could be spherical, it could be cylindrical. Examples or the types of the lenses. A, convex lens. This is also called as double convex lens. And this is how it is made. Both the faces, they got to be convex. This is the left face and this is the right face. Both the faces are convex in nature. B, concave lens, also called as double concave lens. And this is how it is drawn, and I believe that you all have seen it. Both the faces, this is left face and this is the right face, both are concave. C. Plano convex lens. This plano convex lens is drawn like this. Here's a convex surface and this is the plane surface. So, and you can also draw it like this. You can make first the plane surface and then the convex surface. So this as well as this, these two figures, they represent the plano convex lens. D. Plano concave lens, and this is how it is drawn. Just draw the plane surface and the concave surface, and it could be done other way around as well. This is the concave surface and the other face happens to be the plane. Is that right? So you can draw plano concave either like this or like this figure. E. Convexo concave lens. Here is the convex surface and the right side of the surface happens to be concave surface. So this is convexo concave, and you can definitely look for many other type of lenses all by themselves. Now the question is, what is an optical axis of a lens? Optical axis of a lens is also called as its principal axis. Answer. Let us take the case of a convex lens. Complete the sphere whose part is this left side surface. Locate its center. So this center of the sphere happens to be the center of curvature of this sphere whose part is this surface. Next. Now complete another sphere whose part is this right side surface of the lens. Now locate the center of this sphere as well. So this happens to be the center of the sphere whose part was the surface of this lens. Now what you do is, now join these two centers through a straight line. Extend this. This straight line is called as the optical axis. Optical axis or the principal axis. Axis of the lens. Interestingly, centermost part of the lens is called as the optical center, and this lies on this principal axis. So in fact, O, C1, C2, they lie on the same straight line. Now the question is, what is focus or the primary focus of a lens? Let us try to understand first, taking the example of a convex lens, then the example of a concave lens. Here is a convex lens. Draw its principal axis. You need not to draw positions of center of curvature on its either side. O happens to be its optical center. Rays parallel to the principal axis. Here is ray number 1 and this is ray number 2. After refraction, these meet at a point on the principal axis, and this point is called as the focus or the primary focus of the convex lens. Now take up the case of a concave lens. This is the drawing of a concave lens, and this happens to be its principal axis. O is its optical center. Rays parallel to the principal axis diverge and appear to come from a point on the principal axis, and this point is a focus or the primary focus of a concave lens. The next question is, what is focal length? Answer: it is the distance from the optical center of the lens till its focus. As you can see in this first diagram, this happens to be the optical center, and this is the principal focus. Distance from optical center till the focus. This is what is identified as the focal length, F. Now see, this measurement of focal length from optical center till the focus is in the direction of incident ray, and hence focal length of a convex lens is positive. For this diagram, this happens to be the optical center, and this is the focus, and distance from optical center till the focus, this will be the focal length. In this case, measurement from optical center till the focus happens to be in a direction opposite to the incident ray, and that is why the focal length of concave lens is chosen as the negative. Now the question is, define first and the second focus of a lens. Let us try to answer this question carefully one by one, corresponding to figure number 1. So it is the point on the principal axis from where rays emerge and after refraction becomes parallel. So answer: first focus is a point on the principal axis from where rays emerge and become parallel to the principal axis after refraction. This definition is for the first focus of a convex lens. Now corresponding to the second figure, first focus happens to be the point on the principal axis where the rays would have met but becomes parallel after the refraction from the concave lens. First focus is a point on the principal axis of a concave lens where rays would have met but becomes parallel to the principal axis of the lens. Now let us try to understand second focus for the case of convex lens first and then for the concave lens. Second focus of a convex lens happens to be the point on the principal axis where parallel beam of light converges after refraction. And in the case of concave mirror, this point, the second focus happens to the point where rays appear to come from after refraction as parallel beam of light strikes on the concave lens. So let's write it. Second focus of a convex lens is a point on the principal axis of the lens where parallel beam of light meet after refraction. This second focus also happens to be the principal focus or the focus of the convex lens. For this figure, second focus of a concave lens is a point on the principal axis of the lens from where refracted rays appear to come from as parallel beam of light strikes the concave lens. Already mentioned that second focus also happens to be the principal focus of the lens. Dear examinee, here is the next set of 5 questions. Question is, object is placed between optical center and the first focus of a convex lens. Draw the ray diagram for the image formation. So let's do it. Here is a convex lens. This happens to be its optical axis. Let's mark all the important point. O happens to be its optical center. F1 is the first focus. This is 2F1. F2 is the second focus or the primary focus. And this is 2F2. Here is the line of refraction. Object lies between the optical center and the first focus. So here is the object. Ray parallel to the principal axis. It has to pass through the focus. Another ray that passes through the optical center. It must pass undeviated. What we observe is that refracted rays are not meeting. Now what you do? You extend first refracted ray and also extend the second refracted ray. This is the point where the refracted rays meet, and hence this is the position of the image of this object AB. Here AB is the object and A dash, B dash happens to be its image. This image is virtual, erect, and magnified. Next question for you is, object is placed beyond the second focus of a concave lens. Draw the ray diagram for the image formation. You see, you need to practice all the ray diagrams. If you do not practice, you will always be in trouble. Here is a concave lens. This happens to be its optical axis or the principal axis. This point on the principal axis is the focus or the second focus of the lens, and this is the line of refraction. If you do not draw the line of refraction, you will have to show refraction from both of these curved surfaces. So according to this problem, the object lies beyond the second focus of a concave lens. So here is the object. Ray parallel to the principal axis will diverge and will appear to come from the focus. The second ray passes through the optical center and travels undeviated. Extend this refracted ray in backward direction. You get this line on extension of first refracted ray. You get this line on extension of second refracted ray. So this is the point where the image is formed. Corresponding to object AB, A dash, B dash is the image. This image is virtual, erect, and diminished. What is the important point related to this question is, irrespective of the position of this object, image is always formed between the optical center and the second focus. I have a suggestion. Place the object at the focus, try to draw the ray diagram. Will image be formed at infinity? Try it yourself. The next question for you is, the object is placed on the principal axis and beyond 2f. So what will be position and the nature of the image? Here is a convex lens. Draw its principal axis. The centermost point inside the lens happens to be the optical center. This is the line of refraction. This is the imaginary line from where we show the refraction. Yes, for the case of thin lenses. This is the position of first focus. And this is the position of second focus. Let's write now FF once you understand. So this should be 2F on the left side and this is 2F on the right side. All is set. Now here is the object that lies beyond 2F. Ray parallel to the principal axis. After refraction, it has to pass through the focus. So here is another ray that must travel through the optical center, extend it. This is the place where these two refracted rays meet, and we will obtain image A dash, B dash corresponding to the object AB. You must show these arrow signs. The interesting point is, you can start any number of rays from point A. Refracted rays will always meet at A dash. Try yourself. This image is real, inverted, and diminished. So the next question for you is, object is placed at the second focus of a concave lens. Suggest the position and the nature of the image. This happens to be a very unique situation because for the case of convex lens, if you place an object at the focus, this image is formed at the infinity, but this will not be the case over here. I'll show it. In the meanwhile, let's draw the image. Here is the concave lens. This happens to be its optical axis or the principal axis. O is the optical center, and this line, dotted line, is a line of refraction. The second focus, F2, the first focus, F1, object lies on the second focus, ray parallel to the principal axis is refracted and appear to come from the focus. Another ray that passes through the focus, it travels undeviated. Now what you do, you extend second refracted ray in backward direction. Is that right? And these two refracted rays, they appear to meet at this point. So A dash, B dash will be the position of the image. A dash, B dash is the position of the image. You know, this image is formed exactly at the midpoint of O and F2. Next question for you is, the object is placed beyond 2F and moved towards F. Tell me about the movement of the image. Yes, this question is for the case of convex lens. So here is the convex lens. This happens to be its principal axis. O is the optical center. This is line of refraction. This is F. This is 2F on the left side. This is F and 2F on the right side. Now the object is placed beyond 2F. We know that image will be between F and 2F. It will be real, inverted, and diminished. When this object is moved towards a lens and placed at 2F, image is formed at 2F, and this image should be real, inverted, and the size of the image should be same as the size of the object. If the object is moved further closer towards the lens and lies between 2F and F, then the image is beyond 2F. It is real, inverted, and highly magnified. Continue moving this object towards the lens. When it is at the focus, image is formed at the infinity. And if the object is brought further closer towards the lens, though this has not been asked, we know that in this case, image becomes virtual, erect, and magnified and is formed on the same side. Dear examiner, now next set of 5 questions. I will be asking questions. You can always pause the video to answer your question or to write your answer. Once you have done it, unpause it and see the answer. So are you ready? Tell me about the sign convention as used in the ray optics. Answer. We use new coordinate sign convention according to which point number 1, optical center is chosen the point from where distances are measured. Point number 2, distances measured in the direction of incident rays are taken positive while distances measured in a direction opposite to incident rays are taken negative. This is quite a simple question for you. You're supposed to write the lens formula as well as the lens maker's formula. Lens formula is 1 by V minus 1 by U equals to 1 by F. This is, U is the object distance, and of course from the optical center, P is image distance from the optical center, and this is the focal length. And this has to be distance from optical center till the principal focus of the lens. You know what is interesting about this formula is the focal length does not depend upon the geometrical construction of the lens, not the lens maker's formula. It is given by the expression 1 by F is equals to mu2 upon mu1 minus 1 by R1 minus 1 by R2. Here R1 is the radius of curvature of the left side of the lens and R2 is the radius of curvature of right side of the lens. mu2 is the refractive index of the material of the lens and mu1 happens to be refractive index of the medium in which the lens has been kept. Often we write mu2 by mu1 as mu21 or mu. The question for you is, a lens is cut in two identical pieces as shown in the following figures, figure A as well as figure B. So what is focal length of each cut part? In figure A, lens is cut along the principal axis of the lens, and in figure B, lens is cut perpendicular to the principal axis of the lens. Now let's proceed. The focal length of the lens is given by the formula 1 by F is equals to mu minus 1 by R1 minus 1 by R2. When the lens is cut along the principal axis, then the upper half of the lens should look like this. If we see this carefully, we'll notice that in the act of cutting the lens, R1, the radius of curvature of left face does not change, and R2, the radius of curvature of right side face, it also remains unchanged. Even mu2 and mu1 are unchanged, and that is why we expect the focal length of the cut portion, the focal length of the cut part of the lens should be same as the focal length of the original length. Means f dash is same as f. Now let's come to the second part of the figure. In this case, again, the focal length is given by the expression 1 by f is equals to mu minus 1 by r1 minus 1 by r2. Here, r1 is equals to plus r and r2 is equals to minus r. So, f could be rewritten as r upon twice mu minus 1. So this is the focal length of AQ convex lens. When the same lens is cut in two equal halves along a line perpendicular to the principal axis, then the left side of the cut part should look like this. Here, R1 is equals to plus R and R2 is equals to infinity, because this side, this surface now has become plane. Put these values in the lens maker's formula and you will get f dash is equals to R divided by mu minus 1. Now compare this formula and this formula. You should be able to make out that f dash is equals to twice of f. So the focal length of each cut part in this case will become twice of f, twice the focal length of the original lens. The next question for you is, you're supposed to draw U versus V graph for a convex lens, and you are also supposed to explain the method used to find the focal length from the graph. U versus V graph is drawn in the second quadrant. Try exploring why. The graph is like this. Let's try to explore. For U is equals to infinity, V will be equals to what? 1 by V minus 1 by U is equals to 1 by F. Suggest that V minus 1 by infinity is equals to 1 by F. This implies that V should be equals to F. Okay, so this is U, this is V, and U gone infinity, V is equals to F. This is the asymptotic line. This distance should be equal to focal length. This is first point. Explore it further. For U is equals to minus F, let's try to find out the value of V. Again, use the lens maker's formula. 1 by V minus 1 by U is equals to 1 by F, and this variable suggests that 1 by V minus 1 by F is equals to 1 by F. So 1 by V is equals to 0. This implies that V is equals to infinity. So this is the point U equals to minus F. Draw a line parallel to V axis, and this has to be asymptotic line for this curve. Other important point is, draw a line. Third point, draw a straight line at 45° in the second quadrant. If we do so, it has to pass through this point of intersection and should meet on this curve. And let's say that it meets at point minus x comma x. Now substitute u is equals to minus x and v is equals to minus x in the length formula. Then let's see that what do we get as 1 by v minus 1 by u is equals to 1 by f. Suggest that 1 by x minus x is equals to 1 by x. On solving, x is equals to twice of f. So the coordinate of this point should be in reality minus 2f comma 2f. Draw the perpendicular. This point is minus 2f. Is that right? So say minus 2f is equals to minus 20. Then f will be equals to plus 10 centimeter. This will be the focal length of the lens. So the last question from the third set of questions for you is draw 1 by u versus 1 by b graph for a convex lens and explain the method used to find focal length from the graph. Again, this graph is drawn in the second quadrant. This is 1 by u and this is 1 by v. In this case, graph turned out to be a straight line. Ideally, this value should be same as this value, but while doing experiment, we'll notice these will be slightly different. Anyway, the coordinate of this point happens to be minus 1 by f comma 0, and the coordinate of this point is 0 comma 1 by f. Assume this value and this value, they're slightly different. Then 1 by f1 equals to y, and this implies that f1 is equals to 1 by y. And similarly, minus 1 by f2 is equals to minus x implies that f2 is equals to 1 by x. Now what you're supposed to do is find the average of f. F is equals to f1 plus f2 by 2, and this should give you the focal length of the lens. For example, say coordinate of this point happens to be 0 comma 0.10 centimeter. Then 1 by f1 is equals to 0.10 centimeter. This implies that f1 is equals to plus 10 centimeter minus 0.11 centimeter comma 0. Then the focal length 1 by f2 is equals to minus 0.11, or f2 equals to 9.1 centimeter. The average value of focal length f will be equals to 10.0 plus 9.1 divided by 2, and this is equals to 19.1 divided by 2, and this is further equals to plus 9.6 centimeter. So this will be the average focal length of the convex lens in this case. Thank you. If top portion of the lens is painted black, then the refraction of light will take from the lower portion of the lens only, and for this case the image will be formed beyond 2f, and this image will be real inverted, and magnified. Try drawing the course of light all by yourself. Hint is, one of the ray, it could be passing through the focus. It will become parallel to the principal axis. Another ray you can try drawing at any part of the lens, and this ray will not go straight, but it will be deviated. Complete the ray diagram, and this is how the ray diagram could be done. Now the next question. Here is a glowing tube light. It is placed between f and 2f on the principal axis of a convex lens, and the convex lens has a black stripes. The question is, will image also have the stripes? Answer is no. And the reasoning, the image of the tube light will be formed beyond 2f. It will be real, inverted, and magnified. This image will not have stripes, and the reason to it, that lies answer to the previous question. Thank you.